Please, any function you want to work with. Just make up a function. Any function, please. Anyone? Any function. Please, anyone? I know you can. Yes, ready.
Cosine x to the second.
Good. Perfect. That's good enough. Can anyone help us with the derivative for this function? Perfect. Sine squared x. Excellent. Can anyone give us the derivative for sine squared x? Yes?
Would that be cosine square x?
First of all, we have to differentiate the outer function.
Yeah.
The outer function is power 2.
So is it 2 cosine square 2 cosine x?
From 2, we subtract 1. So we bring down 2. From 2, we subtract 1. I haven't gotten to the differentiating sign. I have a function to power 2. I bring down 2. From 2, yes?
So just 2 sine x?
Yes. Times the inner function prime.
Cosine x?
Yes. Awesome. Excellent. Now we want to find the differential. What is the notation for the differential? Anyone, please. How do we denote the differential of y?
dy dx?
dy. dy dx is,
Y.
yeah, so it's dy. Perfect. So then, can anyone give us a differential for this function? Anyone, please. The differential for sine squared x. How do I write it? How do we write the differential for this function? Anyone, please? Give it a try, please. It's okay if you're wrong. Anyone? So the formula is f prime of x dx. That's all you have to say. And I'm just copying 2 sine x cosine x times dx. This is the differential of y. Now, what is the exact difference for a minor error, or the exact change for a minor error in x? How do we calculate it? And again, how do I calculate dy? What is the formula again for dy? Can anyone tell us the formula for dy? It's right here. I just wanted somebody to read it. It's right here. That's the dy formula. Okay, what about the exact change? Do we remember the formula for the exact change? If x changes or has a minor error, what is the actual change in the y value? How do we write it? Anyone? Anyone remembers the exact? Yes?
Is it f of x plus delta x?
Yes.
Minus f of x.
Exactly. So delta y is f of x plus delta x. You can write dx, but it's better because it's delta, but they are the same. So delta y equals f of x plus dx. I'm sorry, delta y equals f of x plus delta x minus f of x. Perfect. What is the relationship between these two? Exact change and the approximation using the derivative. What is the relationship between these two? What is the relationship between these two quantities? Are they equal? One is bigger than the other? How do we know? What is the relationship between these two? Anyone?
I believe delta y is smaller. I don't remember what.
We can never tell which one is smaller or bigger. They are almost the same. They're not equal. They're approximately the same. Good. Any differentiable function at a value can or cannot be approximated by a line, meaning the tangent line at that point near A. It can or it cannot be approximated by a line. So the function is differentiable, of course, continuous, no cusp, etc., etc. So it's differentiable at that point. Can or cannot be approximated by the tangent line at that point near A. It can or cannot. What do you think? It's okay if you're wrong. It can or cannot.
Wouldn't that be a linear approximation? So yes.
So we're going to write them in a minute. Yes. So it can be approximated then.
Yes.
Okay, I agree. So any function that is differentiable at a point can be approximated by the tangent line at that point, near that point. Okay, so now we have, and that's the same definition, it's f of x, f of a, plus f prime of a, x minus a. X minus a is dx, f prime of a, and f of a. And this is the same thing. F of a plus f prime of a, x minus a. This is called the linearization. And of course, this is called a linear. And this is called the linear approximation. This one is the linear approximation with the squiggling symbol. And this one with the equal symbol is called the linearization. Exactly the same formula. And exactly the same formula with the approximation using differentials. Okay, I made a list of topics that you would see on test 2, and now let's start reviewing. All sorts of derivatives, implicit differentiation, logarithmic differentiation. Of course, you'll be asked to find tangents, maybe normal line, etc. The particle that we talked about, the whole list of questions, including the speeding up and slowing down, related rates, approximations using differentials, and of course the linearization. What would you like to start with? What would you like to start with? Do you have any
Okay.
questions? Yes, Evelyn, do you have any questions? Did you encounter anyone? Did you encounter anything in
Yeah, the
WebAssign
log-
that you need help with? I'm ready.
Let me find the question, please. One moment.
Sure. Anyone else would like to start till Evelyn finds her question? Anyone else would like or needs help with anything? Anyone else would like to start or choose a problem?
Okay, this one from the assignment.
Yes, I'm ready.
Y equals 5. I mean, x raised to the power of 5x squared.
Like this.
Right.
Okay. What are we asked to do?
Use logarithmic differentiation.
Okay, so we were asked to differentiate. Very good. So in order to differentiate, because it's a function raised to a function, we have to, step one, we have to apply log to both sides, natural log y, and we bring 5x squared, natural log x. At this point, we will differentiate implicitly. When we differentiate this side, we get 1 over y times dy over dx. This side is a product. So I have to differentiate the first piece, which is 10x times natural log x, plus 5x squared, but times 1 over x. And of course, I will simplify here. So then dy over dx, we multiply both sides by y, x to 5x squared. I copy 10x, natural log x. I simplify an x here, and I have plus 5x. And this is it. That's all I needed to determine. So I determined dy over dx, the derivative of y. Now, you can, if you want, you can just write y prime. That's fine too. There is no need. But that's all I needed to do. Any questions on any of these steps? Any questions? Any questions? Evelyn, is this okay?
Yes, I got it, but I was kind of mixed up and I wasn't sure.
Okay, is it okay now?
Yes, much better.
Perfect.
Thank you.
Thank you. So anyone other questions, or you would like to choose from the topics here? What would you like to start with? Anyone? Any preference? What would you like to start with? Are we okay with all these topics? We don't need any help? We don't need to review anything? Anyone, please? Tom, what would you like me to start with? Or what do you think?
I'm still having trouble with related rates.
Okay. So is there a particular problem that you want to give us so we can work on it? Did you try something? And so we want to start with related rates. Very good. Good point.
Let me pull up WebAssign real quick.
Yes, please. Very good. Good. Excellent. Are you looking at problems or you're looking in the book?
I'm looking at problems from WebAssign.
Okay, perfect. Here they are, and you can give us your problem. So there are 13 questions. I can scroll through, or if you found it, that's even better.
It's number 4.
Okay, very good. You can give us your numbers, that's fine too. A streetlight is mounted at the top of the 15-foot pole. We did this together in class, but let's work on this one. Okay, so we have 15 feet. Okay, so it's right here. Then a man 6 feet tall walks away from the pole. Okay, fine. And as I mentioned, don't ask me to draw a person. I'm not capable. So this is 6 feet. And it says with a speed of 4 feet per second. So is your 4 feet or 4 feet per second, or what is it? What do you have?
For me, it says 5 feet per second.
Okay, so then this is x. This is the distance covered by the person from the pole away from it. So then dx over dt, in your case, is 5 feet per second. Along a straight path, okay. How fast in feet per second is the tip of his shadow moving when he is, what do you have? Do you have 45 feet or something else? It doesn't matter, it's not gonna come
30
into,
feet.
you have 30 feet. So when x is 30 feet. When he is 30 feet from the pole, okay. Good. So in this particular case, if you remember, we worked on this problem in class. So we have here similar triangles. This small triangle, it's a right triangle, is similar to the big triangle, this one. And because they are similar, I have to show why they're similar. First of all, because this angle is common angle. And because this is 90-degree angle and this one is 90-degree angle, so this third one has to be the same, guaranteed, because the sum of the angles is 180. If these two are the same, these two have to be the same. So we showed that the small triangle is similar, that's the notation for similar triangles, to the big triangle. Now I can write proportions with their sides. And the proportions have to be in a specific order. We cannot just punch in some numbers in there or some sides. So I will denote this piece by y. And I will start with the common angle. The common angle has an opposite side in the small triangle, and that is 6 feet. It also has an opposite side in the big triangle, and that is 15 feet. Now, if I move on to the right triangle, I'm not going to be able to write anything because I don't know anything about this, and I don't know anything about this. I'm going to call this A and this B, and it will be A over B. The opposite in the small triangle I meant to say, and the opposite in the big triangle. But I cannot use this because I don't have any measurements. Okay, and finally, I'm right here. I start, all these come from the small triangle and all these come from the big triangle. So once I start, the final step here, this, the opposite is y, and the equal or congruent angle, the opposite is x plus y. And now this is a proportion. 6 over 15 equals y over x plus y. This is a proportion. What happens in a proportion? What can we do in a proportion that we cannot do otherwise? Is there anything that we can do in a proportion that is very valuable right now?
And we call